Alright, the last thing that we're going to do with geometric series is tell whether they converge or diverge, and then find the sum if they do converge. So a series is going to converge, okay, or a series that converges is going to have the absolute value of the r less than 1. And so a series whose sum gets closer to a single number is said to converge. And I'll show you examples of these in just a second and hopefully explain it a little better. A diverging sequence, or a sequence that diverges, is just going to be when the absolute value of r is less than or equal to 1. And so this is going to be a series whose sum does not get close to a single number. Instead, it's going to go way off to negative infinity or positive infinity. And that's not an interval. That's just saying that it's going to go to either negative infinity or positive infinity. And so we're going to look at some sequences that converge. And so I'm going to go ahead and give you some examples on just telling whether it converges or diverges. So I'm going to find the r value to tell whether it converges or diverges. And so r here is going to equal, I'm going to take this term, negative 1/3, and divide it by 1. And negative 1/3 divided by 1 is just going to be negative 1/3. And so the r value, or the absolute value of the r value, is going to be less than 1. And so this will converge. And so what I mean by its sum, if I were to take these numbers and add them all together, they would get close to a single number. And think about it, as I'm going down, okay, these numbers in this series are just going to get smaller and smaller and smaller. If they continue this pattern, I would have like negative 1 over, not 11, I would have like negative 1 over 27. And then I would have 1 over 81, not 18. And then it would just keep going. And so you can see that these numbers are getting smaller and smaller and smaller and smaller. So eventually it's going to be like I'm barely adding anything to it, and it'll be like I'm almost adding 0 to it. So this would be converging, or it would be said to converge, because as I keep adding these terms, the sum is not going to get bigger or smaller. It's just going to get close to a number, because it's almost like I'm going to be adding 0. Now down here, the r value, I would take 70 and divide it by 50, and that would be 7 over 5. And this is definitely going to be bigger than 1, and so this is going to diverge. And so if you think about it, these numbers keep getting bigger as we go along. And so if my numbers that I'm adding are going to keep getting bigger, then my sum is going to keep getting bigger. And so it's going to diverge and not get close to any single number. Now, you can find, like for a sequence that converges, you can actually find the number that the sum gets really close to. And you can do that with this formula. So the sum of an infinite geometric series is just going to be given by this formula. The sum is going to be a1 over 1 minus r. And so you can only use this if the series converges. Because if it diverges, then it's not going to get close to a single number that is this sum. So you cannot use this formula unless your series converges. So we want to find the sum of all 4 of these infinite geometric series. And so the first thing I'm going to do is see if they converge or diverge by finding the r value. So I'm going to take negative 0.11 and divide it by 1.1. And when I do that, I'm going to get my r value. Let's do that in the calculator. Negative 0.11 divided by 1.1 is just going to give me negative 0.1. So negative 0.1 is less than 1, so it's going to converge. And so I'm going to do this formula. S1 equals A1 over 1 minus R. So A1 is 1.1. R, I'm going to do 1 minus a negative. That's going to make that plus 0.1. And so then I'm just going to plug that in. And so 1.1 divided by, I'm going to put the bottom in parentheses, 1. I'll go ahead and type in minus a negative 0.1. That's just going to give me 1. And so it's going to converge to that sum of 1. Alright, now here we need to find what A1 is in this formula and what R is, and see if it's going to converge or diverge. So if I plug 1 in, that would be 2/3. If I plug 2 in, that would be 2 squared is 4 and 3 squared is 9. If I plug 3 in, 2 to the third is 8 and 3 to the third is 27. And so I can tell what A1 is going to be, and I can tell what R is going to be. If I take 4/9 and divide it by 2/3, that'd be like multiplying by 3 over 2. And so that's just going to give me 12 over 18, which will reduce, 6 will go into both of those, so that'll reduce to 2/3. And so the R here is just going to be this 2/3. And so this is going to converge, so I can use my sum formula. And this is going to infinity, so this is an infinite sequence or series. And so I'm going to say S is going to be 2/3 divided by 1 minus my R value, which is 2/3 again. And I'm just going to do this without the calculator because I think it'll be faster and easier. So in the bottom, 1 minus 2/3 is 1/3, and I'm going to take this and flip and multiply, so that'll be 3 over 1. 3's cancel, and I'm left with a 2. So the sum there would be 2. Now, let's try C. So C, the R value is pretty easy to see. It's just going to be 1/3 if I take 1 and divide it by 3. So R is 1/3, so it's going to converge. And so I would do S equals A1, which is 3, divided by 1 minus 1/3. So 3 divided by 1 minus 1/3 is 2/3, and I'll take this and flip it and multiply. So that's like a 3 over 1 times a 3 over 2, which will really just end up being 9 over 2. And so the sum here is just going to be 9 over 2 that this is going to converge to. And then for D, for the summation, I'm going to do the same thing that I did on the last one. So 1, if I plug that in, 1 minus 1 is 0. 5 to the 0 is just 1, and so 1 times 8 would give me 8. If I plug in 2, 2 minus 1 is 1, and so 5 to the 1 times 8 would just be 40. Then if I plug in 3, 3 minus 1 would give me 2, and then 5 squared would be 25. And then if I multiplied that by 8, 25 by 8 would just be 200. And so then we can see what the R value, or what the R value is going to be on this one. And so this one is going to be 40 over 8 for R. And so then I can tell that the R value is just going to be 5. And so because this one, the R value is 5, that means it's not going to converge, okay, because the R value is, and I wrote this one wrong. This should be, this should be greater than or equal to 1. And so it's going to diverge if it's bigger than 1. And so this one should be diverging. And so if it ever diverges, it has no sum. Alright, so determine if each series is arithmetic, geometric, or neither. If the sequence is arithmetic or geometric, find the common difference or ratio. Alright, so on this one, these are just some of the problems that are at the end of the worksheet that I'm going to give you that I felt like a lot of people would be confused on. So let's just go ahead and try some of these. So it says determine if it's arithmetic, geometric, or neither. And so in order to do that, I need to generate a few terms of the sequence. So A1 would be 2 times 1, which is 2. 2 times 2 would be 4. 2 times 3 would be 6. 2 times 4 would be 8. And so I can tell that this is going to be arithmetic because the D value is 2. And so if the sequence is arithmetic or geometric, find the common difference or ratio, and then that would just be that, the D20, or D equals 2. And so then if I wanted to find S20, because this is arithmetic, I would use this formula, N over 2, A1 plus AN. And so S20, the sum of those 20 terms would be 20 divided by 2. A1 would be 2. AN, I would need to find values in this formula. A1 plus n minus 1 times D. So A1 is 2. N would be 20. And then D would be 2 also. And so if I do all that in the calculator, that's going to end up being 2 plus, that'd be 2 plus 19 times 2. And so then that's just going to be 40. So I'm going to plug 40 in right there. And so when I do all that in the calculator, that'd be basically 10 times 42, which is just going to be 420 if I add those up. Alright, let's decide if this one's arithmetic or geometric or neither. So if I take 27 and divide it by 81, now I'm going to 27 3 times, now I'm going to 81 9 times, 3 will go into 1 3 times. So I'm just reducing this to 1/3. And so R is going to be 1/3 here. And so it's not asking us to decide whether it converges or diverges. It's just asking us to decide whether it's arithmetic or geometric. It's going to be geometric, and I could tell because I found the R value, or I could just look at this and see that I'm dividing each one of these terms by 3, which is the same as multiplying by 1/3. So if I wanted to find S10, and I know this is geometric, so S10, I would use this formula, A1, and then 1 minus R to the n, all over 1 minus R. So A1 is 81. 1 minus R is going to be 1 minus 1/3. And I would raise that to the 10th, all over 1 minus 1/3. And so when I plug this in, I'm going to do 81 times 1 minus 1/3, raised to the 10th. And then I'm going to go ahead and divide this. 1 minus 1/3 in the bottom is going to be 2/3. So I'm going to go ahead and divide that by 2/3. And so when I get my answer, I should get this big fraction, and that's okay because some of your answer choices on your review and your test are going to be kind of weird and big like that. So 29,524 divided by 243. And so that's going to be my sum of the first 10 terms.